Hi, welcome to Lattice Developer Conference. Hope you are enjoying all the sessions. In these sessions, I'll be presenting deployment of Edge AI applications on our sensAI solution stack. Uh, my name is Shripal Hegde. I'm working at Lattice Semiconductor from last 14 years. I have uh, I'm involved in sensAI solution stack development from since the beginning, and currently my team is responsible to develop the entire solution stack, which includes many components as we see throughout this presentation. Uh, with that, here is the agenda for the presentation. Lattice sensAI, we will dive deeper into what is sensAI solution basically, and what are the advantages of FPGAs when it comes to AI ML at edge, that we will review it, and methodologies and tools that we provide to simplify further deployment of the solution. And similar, we will also take a couple of case studies, and then we will summarize the whole thing for you. Right. So Lattice sensAI basically is a solution stack that enables our customers or the end application developer to deploy the models trained neural network onto our FPGAs, right? So it's basically inferencing engine that enables after the model is trained. So normally models are deployed at the edge near the sensors, and to enable those edge deployment, we provide a complete solution stack. As shown in this slide, basically it consists of the engine that is very efficient in terms of execution of a neural network inferencing, and then we provide the tools that will enable taking all the way the trained network and do the things like quantizations and things like that, and put it onto our engine, right? So that's basically many times it's referred as a runtime. So our compiler tool generates the runtime for the engine. At the same time, we also provide other tools like the training framework that enables user to do the transfer learning, or like basically if you have the model, that we provide many reference models, and if you want to train those models with your own data set, we provide the framework that enables it, right? So similarly, we do understand that many users need an easy way to put the systems together and bring up. There are multiple users, as we see later in the presentation. We call it as user personas. Some users are not very comfortable dealing with the hardware nuisance, bringing up the board and things like that. Some users may not be so comfortable with the ML. So we provide the tool suite that covers the entire spectrum, right? So we cover on one end the ML experts who wants to easily deploy their models. On the other hand, there may be a persona of users basically who are not comfortable with AI ML, but they are very comfortable. They have a lot of data set. They want to take any of the existing model and train it, right? So we cover the entire spectrum with our tool set. So then basically, as I mentioned earlier, also we provide quite a bit of reference designs models. Reference designs basically consists of some of the trained neural network for various end application. Also, in many cases, it also has, in many cases, we integrate with RISC-V so that it becomes more easier to do the control flow. The image pipeline basically can be customized with the RISC-V programming, right? So we again we touch upon various of this aspect as we go through the presentation. So all these things, along with the many collaterals, documents, and things like that, forms what we call a sensAI solution. In another way of look at this is a layered stack, right? So we provide like various hardwares, kind of a platforms, FPGAs, kind of a thing, boards, reference boards, and on top of that there are many IP cores that we provide for the end users. Then there is a software component of it, then the reference designs, and even we provide end solutions for many application. So all these together, put together, we call it as sensAI solution stack. So since its inception, it has won numerous recognitions in the industry, and more than that, it is the solution is deployed in the real life designs, right? So here are some of the real life application examples where sensAI solution is being actively deployed in the field. Uh, Example is like user presence detection when somebody walks in and then basically laptop or it kind of wakes up, right? So kind of thing. Otherwise, when no one is present in the room, it can go into sleep mode. Those kind of things, right? So similarly, attention tracking. If someone is looking at the monitor or they are looking somewhere else, so for a longer time, if they are looking not at this monitor, then it can be dimmed. Basically, you can save the energy, so battery life, right? So similarly, onlooker detection. So if you are using in airport or some other public place your laptop, and if somebody is trying to stare at your monitor and kind of thing, it can blur or kind of warn you that someone is trying to look at your screen, kind of a thing, right? So similarly, face framing is very common in the conference and those kind of providing a very good experience to the user in those systems, right? So these are some of the examples, real life examples where we can see the active deployment of Lattice sensAI. So now that brings to the question, what is so unique about Lattice sensAI solution and why FPGAs are good for edge AI or the neural network inferencing at the edge, right? So there are a few inherent characteristics of edge AI, right? So first and the foremost is the parallel computation. So as many of you are aware, the neural networks, basically, particularly in the convolution neural network, there are operations like convolution operations and things like that that are uh, they have complexities, right? So they are polynomial complexities where basically you need to make sure things are executed parallelly, otherwise you cannot meet the end application requirement, the response time, the latency, and those kind of things. So basically that's why we have uh, the FPGAs provides those parallel computation capabilities, right? So and we can accelerate the execution, even the memory and things like that. It's not just the computation part, it's also the data movement, right? So if you look at the complexity, data computation is the one complexity. Second complexity is moving the data, right? So FPGAs provide the fabric which will enable the movement of the data in bulk, right? So that's basically one of the advantage that brings FPGAs in a unique position when it comes to AI. So add to that the uniqueness of Lattice FPGA, which is a low power FPGA, right? So which will enable basically many of the edge application. So which will put a Lattice FPGA in a unique place compared to other generic FPGAs that are available out in the market. So again, another beauty of FPGA is highly configurable, right? So here we are talking about like you can create the system depending upon the operations that are used in the neural network. So you can do many of the things that are traditional not possible with ASIC or ASSP. So you can basically configure the FPGA in a customized way to the end application, right? So that's another beauty of the FPGA and why it is suitable for edge application. Similarly, another important advantage that is normally not talked so much is the expandable I/O capabilities, right? So ML is not just neural network, right? So that's the core of the thing, right? So you need to enable your end application with AI ML with the trained models and things like that. But to get the data from sensor to the engine, so always there is a lot of pre-processing. For in case of image processing, you need to kind of change the resolution of the camera when it is fed to the model, and even as a post processing many times you need to do the processing to present the data to the real world, right? So pre-processing and post-processing are important. Similarly, there is quite a bit of memory involved, right? So in some time, you want to use a system that has only embedded memories used, right? So only internal memories. FPGAs comes with quite a bit of internal memory, and that suffice many of the application. In some application, you want to use the external memories like DDRs and things like that. So the solution provides that flexibility. Either you can go with the external memory or you can go with only internal memory based solution. The same network can be targeted for multiple different system configuration, wherein basically along with the IO configuration and the system configuration. So it's quite a bit of it becomes an expandable solution. So right, so that's another advantage of FPGA. So, and I did mention earlier, Lattice is in a very unique position because of its form factor and the low power, right? So we create a small form factor FPGAs that are good for a deployment over the edge, right? So in a near sensor kind of a application where even the power many times is very critical, and we play a key role in reducing the overall system energy consumption, right? So and also Lattice does not provide just one FPGA. We provide a suite of FPGAs, multiple devices, which comes with various form factors and things like that. The same engine, when targeted to different form factor and kind of FPGAs kind of a thing, it opens up a lot of new opportunities for end application deployment. Right. So here I have shown, for example, some devices will come up with 24 DSP, 1 megabit RAM, and 10K LUT. LUT basically stands for lookup table, which implements basically some of the logic, those kind of thing, and distributed RAMs basically that are inbuilt inside the FPGAs. All these things can be configured within the same device. You can even configure, okay, I don't want to use all of them, all the DSPs for ML application. Let me reserve some of the things for the pre-processing and post-processing. That is quite possible with our FPGA. Now, after looking at all these advantages, and then basically we are talking about these advantages based on the experience of deploying it in the real world, right? So it's not uh, now the another important thing that anyone should look into while choosing a solution is the maturity of the methodology and tools. As the things are deployed in the real world kind of thing, we have learned over many years what is the right methodology, what is the right tool, how to do the closing with in terms of accuracy, in terms of the performance, the frame per second, what is really required, right? So it's not just the theoretical computation. So now, based on that, we have created a flow or a tool methodology wherein user can easily deploy the trained network. In fact, they can even do some of the training using our provided software and solution. So if you look at this diagram, basically it captures all the tools that we provide. Okay, so of course, those who are familiar with the FPGA itself, they will immediately recognize some of the tools that we provide, Radiant and Propel. Those things are traditional FPGA design tools. But even if user is not familiar with these tools, we provide a ready-made kind of a cooked up solution engine that can be easily programmed onto various devices, right? So we provide the fixed bit streams for many deployment application using system generator and other tools, right? So that's another thing. So that means it's caters for a wide range of user spectrum, right? So if you are familiar with FPGA, yes, you can go and use these tools. If you are not familiar, then also fine. We provide a more abstracted tool for you, system generator, that will enable you to program into FPGA. Now, those who are from the ML world will immediately relate themselves with these tools that are provided up, right? So particularly quantization aware training is critical for deployment of any model at edge, right? So unless the models are quantized for low precision, so it cannot be run on a small device, particularly at the edge. This is a well-known fact, like 8-bit quantization. I mean, people, in fact, 4-bit, and those data weights are becoming very popular in neural network inferencing. And for that, the core is the quantization. Okay, when you do the quantization, there is a loss of basically accuracy. Now we provide a solution wherein we kind of do the simulation and fine tune the model so that we don't lose the accuracy to a great extent, right? So it's a very unique solution proposition that we provide to minimize the loss of accuracy. And neural network compiler is at the heart of the whole tool suite, where it will basically generate the runtime for the neural network to do the inferencing on our FPGA, right? So basically, if you are familiar with TVM or TensorFlow Lite and things like that, this is very similar to that. Neural network compiler from Lattice will provide an equivalent of that to do the inferencing on any on our Lattice devices, right? So now, here are again some more breakdown of all the tools that we provide and what exactly it's doing and those kind of a thing, right? So model training, basically, as I mentioned earlier, it's we provide quite a bit of models that are already pre-trained, and we do that so that the models are highly optimized for our solution when it runs on our small devices with a small memory footprint and those kind of things. Those models can be retrained, or they can you can do the transfer learning or incrementally fine tune those model with your own data set, right? So that's basically so the uh, and also the models can be quantized and saved in various different format and things like that, and kind of a thing, right? So we support both quantization, like quantization during training and post-training quantization, and we will talk a little more detail about the quantization itself because it's very important for neural network inferencing, right? So we will touch upon that in little more depth. So the quantization, basically based on our experience, right? So most of the time it's better to do the quantization during the training itself, right? So for a better accuracy and getting a good result out of the models that are targeted for small devices, right? So, or edge devices. Now, of course, we do provide post-training quantization methodology or the script and those kind of things, because most of the time user wants to take their models that are available after the training and target to our device and see whether what is the accuracy they get, or what how well. In many cases it may suffice the end application requirement and you don't have to do anything. In some cases, or kind of a thing, you may want to do the incremental tuning with quantization, right? Or in some cases you want to uh, do the quantization during the full-blown training itself. We provide APIs to do the quantization, which is based on learned step quantization. Okay, so for more details, you can refer to the paper that is mentioned here. But we did not adopt this. We did many enhancement or changes to this concept presented in this paper and provide it as an API, right? So because we wanted to make sure this even quantize the step size also, right? So there are many things that we wanted to do on top of what this paper proposed as a methodology. And for end user, we provided a complete package, the APIs they can plug in with their training environment, or they can use the training framework that we provide. Okay, both the things works, right? So either you can take these APIs and plug into your training environment, or you can use our training script and or the framework completely to do the model training, right? So that's highly recommended, in fact, right? So now the neural network compiler, as we discussed, right? So it generates the runtime, right? So for the ML engine that basically does the neural network execution. Now the ML engine is configurable, right? So it can, in terms of the memory, in terms of the DSP unit, in terms of all these configurable parameters can be kind of considered during the compilation itself, during the runtime itself. It's easily configurable from the compiler perspective, right? So kind of a thing. Now, now, there are many supported networks and models that we highly recommend based on our experience of deploying these solutions onto production. So, for example, MobileNet V1 and V2 that has done a great job for many end applications where the power and the performance and accuracy. So it's a good balance. It provides a very good balance of all these parameters for the end application, right? So we highly recommend that one. And similarly, YOLO is a very good network, and we support up to YOLO V5. Of course, we have a roadmap to even enhance our tools methodologies to the upcoming. That's what I mentioned earlier also. One advantage of FPGA is you can support new operations, new network topologies as the field is still evolving. Okay, so there are a lot of research is still happening, and people are finding, okay, some new operations or topology is good and kind of a thing. We will be able to adopt those things as we are working with FPGAs, right? So we support SSD, squeeze detect, many ResNet variations, and so a lot of other models. In fact, all these models can be customized. So this basically most of the time we take the published network topology and models. It always needs tweak for the end application. What is good for that particular application, how to balance it. That's what most of the model creation engineers will do. So we provide easy feedback to them, okay, how their changes are impacting the end result, end inferencing kind of a thing, right? So that kind of a feedback loop will enable to close on the model quickly, right? So and similarly, model zoos that we provide also act as a good reference, right? So a starting point in many cases, right? So where user can start with those models instead of developing from scratches, right? So or in many cases it is can be directly used as is, right? So kind of a thing. Now, the tools and methodology is important. At the same time, the heart of the whole solution is the ML engine, right? So that the engine that has been tuned, highly optimized for neural network inferencing, right? So that's the core of our technology, which basically enables efficiency, right? So kind of a thing. Now, we have developed multiple engines, not just one engine. Basically, this will help good trade-off between the performance, okay, and as well as accuracy, performance, any of the parameter that you care for the end application can be tuned with multiple engines. And another reason is we have a array of devices, not just one devices. So many times when you go for a very small device, right, so the engine has to be tuned to work with those resource constraint, the number of DSP blocks, memory blocks available, and things like that. As a result, we provide a various different engines, multiple engines. Each engines are again configurable, and they can be each engine can be targeted to more than one devices most of the time. So it provides us a good kind of permutation and combination that user can try in terms of basically what can be achieved, right? So to enable this permutation and combination, we thought, okay, the best way to enable the user is with a system generator. Okay, now the system generator, basically what it does is it takes multiple input. Okay, so first input is of course the input from the user, where user can provide the input in terms of the application requirement. Okay, what is the frame per second requirement or the performance required? What is the accuracy required? What is the latency requirement? So even they can talk about, okay, whether they have external memory or they want to stick only with the internal memory, how much memory is available, some of the user level, even the power requirement, some of those things can be captured with a GUI tool as a system specification, right? So that's the one of the input thing. Second input is neural network model itself. Model does carry a lot of information, like what kind of operations are used, what is the hierarchy, what is the max memory required during the inferencing time, and those informations are already there in the model itself. So we take the input as a model itself as the input to this system generator, right? And then of course we have many ML subsystems and templates that are already kind of stored in a library, and that act as a basically input to the generator. As a result, this all these inputs are considered to tune the system for various configuration and basically come up with a recommendation for the user. Okay, this is the most optimal solution for your end application, right? So that kind of capability we have built and we are kind of providing to the user, and particularly all these works are based on, again, some of the experiences we gained while deploying the application as an end product, right? So we want to kind of capture those learning as a tool, not as just a document or something like that, and enable our end customer, right? So and then basically it spits out the system something like this, not just the ML engine. Okay, we tune the ML engine parameter with all these things, with various, okay, what are, if some operations is not used, then we will simplify that. Okay, we will not have that in the ML engine. Okay, it reduces the complexity of the ML engine itself. Number of cores gets configured, and similarly many of the pre-processing and post-processing blocks gets decided based on some of the things. For example, if there is a camera resolution and then there is a model input resolution, if they are not matching, then basically we need to insert a scaler that basically enables user to scale down the image and things like that, right? So similarly we integrate with the RISC-V and processor. It's not mandatory for ML system, our solution, to have a processor, co-processor or a processor, right? So it can work independent of any host, or it can be deployed. The engine is self-sufficient. But at the same time, you can use the embedded processors also within the FPGA itself, or you can even interface with the external processor. In some cases, it enables the data flow and things like that, right? So most of the time, the heavy lift is done by ML engine, the computation, and RISC-V is enabling the data movements or the control path, right? So that's basically what the RISC-V is doing in most of the solution. So now, let's move on to some of the case study that will probably further highlight some of these tools, methodology, and putting everything together, right? So first is the face landmark design, right? So this is again a very important design in our suite that shows the landmark on the face, right? So we use here a MobileNet V2 or a variation of that model, I should say, because there are so many variation of MobileNet V2, and we do some changes to adopt that model, and the input resolution of this model is basically 96 by 96, right? So that does not mean the camera resolution is 96 by 96. Always the camera resolution is higher. We go all the way up to 4K camera, in fact. So in many cases, we need to do kind of a pre-processing to adopt the video pipeline, right? So kind of a thing. So and again, we detect 23 landmarks that will enable various application, end application, right? So even onlooker detection. So this is the first application in the many pipeline, actually, in the application pipeline. So detecting the landmark of the face enables other application down the pipeline. Right. So now, of course, we just to show the example in this one, the quantization. Okay, so we discussed about the importance of the quantization while deploying the model onto our solution. Right. So now with the float 32, the accuracy of this model or mean average error is basically 1.099. Right. So and with FPQ, so with post quantization kind of a uh, post training quantization kind of a thing or fixed point quantization, you will get 1.88 kind of a accuracy kind of a thing. Now, if you learn the step size and then do the quantization during the training itself, so the accuracy will be much closer to the float 32, right? So it's of course there will be some loss when we go from 32 to int 8. It's of every application then again with the training, with the model changes, a lot of things can be tuned, but at the same time it gives a better accuracy compared to the fixed point quantization that was supported in the previous releases, right? So those are the enhancement that enabled some of the deployment of the application, right? So now uh, LSQ also helps to reduce the data width, right? So now instead of going only int 8, we can even further go for int 4, right? So some of the even because earlier when the loss gets minimized, okay, now there is a freedom in terms of the model size reduction. Either you can go with int 8 and reduce the number of layers or something like that. In some cases that is possible, or in some cases you can say, okay, I want to mix int 4 with the int 8 and then go with a mixed precision kind of a thing. That's also possible. And in some cases you can say, okay, int 4 is good enough for me in all the convolution layer so that it drastically reduces the memory footprint, right? So getting a very good memory utilization kind of a thing. So here we captured again some of the uh, MAEs basically for different combination. Now these things you don't have to worry. Automatically tools comes up with this kind of accuracy numbers and recommended kind of thing, measurements and things like that, so that the application developer can choose, okay, what is the right thing to do in terms of the quantization, in terms of the width, and in terms of the end performance goals and those kind of a thing. It provides quite a bit of flexibility because of some of these advancement we have made in the tool. So the another application that we just want to discuss in this presentation, of course, because of the time limitation, we won't be able to go over all the applications that we are shipping today. One interesting thing is the barcode detection, right? So basically, this is traditionally barcodes are scanned one at a time and very inefficient way of doing things in many cases, right? So with the image processing, you can read multiple barcode, detect multiple barcodes, or when it is moving on the conveyor belt, or when it is even standstill and things like that. So this is one of the we were engaging with customer who are interested to kind of solve this kind of problem and wanted to see how our solutions can enable them, right? So in detecting multiple barcode and things like that. So we did a proof of concept. We kind of this is not a final production class use case. This is more like a POC. So the earlier one is more like a production class, right? So phase detection, landmark detection. So those kind of things. So we provide both final solution as well as the solution that shows a proof of concept, so that you can take it further with the training and your enhancement and unique value proposition that basically you want to add onto our solution, right? So here again, the input resolution, for example, from the camera, actually this is for the model itself, we work with 320 by 240 QVGA kind of a resolution, right? So that's the input resolution of the model. We did not go with any kind of image resizing and those kind of. Now basically And we trained with a 5K data set. Actually, the data set was 5K, but we did quite a bit of augmentation with those data set and increase the size of the data set to take care of different distances. For example, that's one of the important criteria given to us. Okay, it is not fixed distance. Okay, the distance can vary. Now the data set comes with okay all fixed size kind of image sizes. Okay, now you have to vary the aspect ratio so that basically you can measure from different distance and things like that, right? So now that's basically what is shown here. We tried multiple different models. Okay, again, this is just an experiment, and never to say one model type is better than the other. These are the measurement we did for this particular application. There could be n number of variables wherein for a different application YOLO may be better than MobileNet V1. But in this particular application, we found MobileNet V1 is good enough, right? So it's a very simple network, not with much complexity and things like that, which gives a very good accuracy and a very good memory footprint. So you don't have to always go for a very complex network, right? So depending upon the application, there are options for you to go with a simpler ones, right? So that's basically the choice you need to make. It's not always okay go with the latest available network or the most complex network. That's not true, right? So that's why we have various flavors in our model zoo, so that there is a good starting point to explore on the network topologies and things like that. Now with that we will come to the summary basically. So now, a Lattice solution, again, we provide a low power FPGAs that are perfect for many edge AI inferencing thing, right? So, see, even outside of edge AI also, our Lattice FPGAs are quite popular because of its low power and small footprint, right? So, the same advantage amplifies when we enable ML inferencing on a very small, tiny device, right? So, the lot of options opens up in terms of the solution creation and application creation and the market that you want to target. So there quite a bit of option opens up for everyone, right? So kind of a thing. Now again, the second thing I want to highlight is the production readiness, right? So it's a production proven, it's deployed in the current in the product that are out in the market kind of a thing. So now there are advantages of that proven thing, right? So all the experience we gained as a part of that product, taking it to the production, now we are pushing it to all the customers, right? In terms of various tools, methodologies, in terms of the IP that we kind of customized and those kind of things. So it's a production proven solution always helps the end customers even in other areas kind of a thing. So new features like the 4-bit and 8-bit data width and learn step quantization, all these things really has taken this solution to the next level, right? So this is the right time to adopt the solution because it's there for for the end application requirement, meeting the end application requirements, right? Whatever you want to achieve and those kind of things. And we constantly improve this. It's not never less to say there is nothing more to do here, right? So always there is something more to do. And in fact, earlier we supported binary neural networks also, BNN also. We want to see whether how that fits into the combination of 4-bit and 8-bit with a binary kind of a thing. So there are some roadmap items that are very interesting, and those who are kind of adopt this solution definitely will see the benefit, and they can directly engage with us as an early adopters, right? So kind of thing. Now, reference designs and models, again, we have quite a bit of models in the model zoo. Strongly recommend to start there. That's the good starting point for most of the application creation, right? So, and now with that, it completes the presentation, but at the same time, I wanted to take few frequently asked question. I might have touched upon it as part of my presentation already, but nevertheless, I want to touch upon few frequently asked question, right? So kind of a thing. So one of the things that normally people ask, okay, what is the performance on various networks like ResNet, MobileNet, YOLO, and all this network topology? What is your performance, right? So natural. So now there are various ways of measuring the performance, right? So TOPS is one common method everyone likes to use it, or in frame per second. So there are various methods. So always the performance measurement is little tricky given that Lattice is not providing one solution or one IP, one engine, right? So it's multiple engines are there. There are multiple devices, multiple FPGA devices are there. And for each device, again, the frequency at which you can run these devices changes. We call it a speed grade and things like that, right? So it changes. Now, based on that, depending upon where you target, it drastically changes. Okay, so we have achieved anywhere from like 120 frames per second in some of the mobile net models and kind of a thing. So on a again a real application kind of a thing. So and at the same time, if you are targeting a very resource constrained, very small thing, and in fact you may not need that, right? So even 30 frames per second may be good for in many applications, and we have the optimized engine for those kind of things, right? So requirement. So it varies. The performance numbers really varies, right? So kind of a thing. Now, how much hardware designs or RTL coding user need? So this is one of the concern used to be there when we rolled out the solution, right? So because everyone used to say, oh, FPGAs, okay, I don't know anything about FPGA. How do I use it? Now we did understand some of those issues, and we rolled out tools like System Generator that will abstract out all the nuisance within the FPGA flow and basically provides the fixed bit stream wherein we just program the chip, right? So device. Okay, so you just bringing up the device and then running the neural network on that. In sense, you don't need to know anything about RTL coding. We provide all the required blocks, all the designs, including the image processing pipeline. So all those things are available to you. Okay, so if you are just an ML engineer, it's very easy to buy the board on our website and try it out, right? So kind of a thing. But if you are an FPGA user, definitely there are some cool things you can do with RTL coding, right? So you can always take advantage of FPGA flow and your expertise in those kind of a thing and enhance the solution on top of what we provide, right? So that's quite possible. Now, what are some of the restrictions of Lattice sensAI and why do they exist, right? So mainly there are restrictions in terms of the operators we support, right? So we don't support, it's not a generic neural network inference engine, it's a CNN neural inference engine. So CNN based network operations are well supported. The reason is we want to create a very efficient inference engine. If you create a very generic, we will be one of the other solution where it won't be efficient or performing to the requirement of the application. So that's why we, of course, with multiple engines, we can target different options and things like that. Even then we restrict, okay, what is really required for end application creation. We focus on that, right? So kind of a thing. Now, can Lattice sensAI core operate standalone? Yeah, I did cover this, right? So it does not require additional processor. It is standalone, right? So it can operate without interface, but at the same time we provide interfaces to many hosts and RISC-V core integration. So there are a lot of again options opens up with the kind of interfaces we provide with various hosts. What debug capabilities exist in Lattice sensAI? This is a good one. So one of the thing I did not mention so much is the simulator. In one of the slide I did cover simulator helps those who are training the model to close the loop very quickly based on the quantization and other things that we are supporting today. Similarly, the other debug capabilities on-chip debug capabilities. We do provide, okay, each layer, if there's you can read back the value and see what is going, what is working and what is not working, right? So some of the advanced debug capabilities are available in sensAI for user to use and explore kind of while doing the application, right? So that basically concludes my presentation on sensAI. There are quite a bit of document available online, and we have a lot of resources, kind of a thing. Feel free to contact our sales channel or FAEs. So definitely you will get needed help to get started with our solution. Once you start, then you will feel okay how simple it is to adopt and use and kind of a thing. And there are quite a bit of learning material also available for those who wants to explore the edge AI deployment on a resource limited devices, right? So with that, again, I wish everyone have a good time with Lattice Developer Conference with a lot of learning and networking and those kind of a thing. Have fun and look forward to hear back from you folks regarding the solution that we provide on Edge AI deployment. Right? Thank you.